This measures how well t-SNE preserves the relationships between nearby data points when it shrinks high-dimensional data to a lower dimension. Think of it like this. Imagine you're squishing a clay model. A high trustworthiness score means you kept the parts that were close together and ones farther apart far apart. The trustworthiness score is always a number between 0 and 1, inclusive. 1 means perfect preservation of the original neighborhood relationships. 0 means no preservation at all. It's a handy way to evaluate how well t-SNE performs its job. I see a low trustworthiness score as a red flag. It tells me that t-SNE may not be the right tool for visualizing this particular dataset. The underlying structure of the data is not well captured if the score is low. We might need to explore alternative dimensionality reduction methods. A score of 1.0 means that t-SNE has done a perfect job of keeping the close together points close together and the far apart points far apart. It's the best case scenario. This is simply stating the range of possible trustworthiness scores. It's always between 0, worst, and 1, best, including 0 and 1 themselves. I'm looking at how well t-SNE preserves the relationships between data points when it shrinks the data's dimensions. Think of it like this. You have a group of friends who are close in a big city, high-dimensional space. t-SNE tries to place them on a map, low-dimensional space, so they remain near each other. The trustworthiness score tells me how well t-SNE did that. This question is asking me to evaluate statements about the trustworthiness score, which I understand measures how well t-SNE keeps the relative distances between data points in the low-dimensional visualization. A score of 1.0 is perfect. It means t-SNE flawlessly maintained the neighborhood relationships in the simplified visualization. That statement is backwards. A score near 0 means t-SNE did a terrible job of keeping the data points organized like they were originally. Yes, the score is always between 0 and 1, with 1 being the best. It's like a percentage, 0% to 100% for how well t-SNE did the job. A low score? Yeah, that's a big red flag. It probably means t-SNE is not the best tool to visualize this specific data, since it's messing up the relationships between the data points. This is the core idea. I'm evaluating how well the t-SNE algorithm, t-distributed stochastic neighbor embedding, keeps the original structure of my data. t-SNE is a method to visualize high-dimensional data in a low-dimensional space, like 2D for easy plotting, while trying to retain the important relationships between data points. This is my starting point, data with many features or dimensions. Think about something like images. Each pixel could be a dimension. It is difficult to visualize this type of data directly. This is the process where t-SNE transforms high-dimensional data into low-dimensional data. It's like taking a complex 3D object and making a 2D shadow, but trying to preserve as much information about the original 3D object as possible. This is the result of the t-SNE transformation. I'm getting a simpler representation of my data that is easier to plot and visualize. For example, I can plot my data on a 2D scatter plot. This score is the critical measure of how well the t-SNE transformation preserved the relationships, distances, between data points. A higher score, closer to 1, is better, meaning the low-dimensional representation remains fairly similar to the high-dimensional data. This is the overarching concept. How well does my visualization reflect the original data? It's a crucial metric to understand when using t-SNE to visualize data. This question tests your understanding of the trustworthiness score, a metric used to evaluate how well a dimensionality reduction technique like t-SNE preserves the relationships between data points when transforming high-dimensional data to low-dimensional space. I'll guide you through analyzing each statement. The trustworthiness score measures how well the neighborhood relationships in the original, high-dimensional data are maintained after applying t-SNE. A higher score means the data points that were close together in high-dimensional space are still relatively close together in the lower-dimensional visualization. It's a key indicator of how effective t-SNE is at preserving the structure of your data. A score of 1.0 is the best-case scenario. It means that t-SNE has flawlessly captured the neighborhood relationships. Points close together in high dimensions remain close in low dimensions. Perfect preservation indeed. This statement is incorrect. A score closer to 0 means the low-dimensional representation fails to preserve neighborhood relationships. The closer to 0, the worse the preservation. That's correct. The trustworthiness score is always between 0 and 1, representing the range from completely failing to perfectly preserving local structure. A low score suggests that t-SNE may not be an appropriate method for your data because it hasn't captured the essential relationships within the data. You might consider trying another dimensionality reduction technique. Think of it like trying to fit a square peg in a round hole. This is the final result, a single number representing the quality of the t-SNE embedding. It summarizes the extent to which the embedding has successfully maintained the neighborhood relationships in the data. This is what the statements and the questions are about. This refers to your original data, likely with many features, variables. It's difficult to visualize this type of data directly. This is the process of applying the t-distributed stochastic neighbor embedding, t-SNE, algorithm. TSNE is a specific algorithm designed to reduce the dimensionality of data while trying to preserve the local neighborhood structure. It aims to transform your high-dimensional data into a lower-dimensional representation, usually 2D or 3D, for visualization. This is the result of the t-SNE transformation, a lower-dimensional representation of your original data, suitable for plotting and visual inspection. The trustworthiness score helps you determine if this representation accurately reflects the relationships in your original data. I'm going to explain what a trustworthiness score means when you're using TSNE, T-distributed stochastic neighbor embedding, a technique for visualizing high-dimensional data in a lower dimension. It measures how well the relationships between nearby data points in the original, high-dimensional space are maintained after the t-SNE transformation. A higher score means the relationships are preserved better. Think of it like a map. A high trustworthiness score means your map accurately reflects the distances between places in real life. This statement is incorrect. A trustworthiness score near 0 means the low-dimensional representation does a poor job of keeping the relationships between nearby points the same. The closer to 0, the worse the preservation. It's the opposite of what the statement says. Remember, a high score means a good representation. I agree with this one. A low trustworthiness score tells me that t-SNE might not be the best choice for visualizing your data. If the relationships between the data points are not preserved well, the visualization won't accurately reflect the data's structure. It might be worth trying a different technique. I see this phrase, and I understand it refers to a specific metric used to evaluate how well t-distributed stochastic neighbor embedding, t-SNE, a dimensionality reduction technique, preserves the relationships between data points when reducing the number of dimensions. A higher score means the relationships are better preserved. I see this as the main question in the quiz, asking you to identify true statements regarding the trustworthiness score from t-SNE. We will analyze each statement individually to determine whether it is accurate or inaccurate. I see this statement as true. A score of 1.0 means that all the neighborhood relationships between data points in the high-dimensional space are perfectly replicated in the lower-dimensional space created by t-SNE. I think this statement is false. A score closer to 0 implies that the neighborhood relationships are poorly preserved, not better preserved. A lower score means the algorithm failed to maintain the spatial relationships between data points effectively. I'm seeing this as also true. The trustworthiness score is always in the range of 0 to 1, inclusive. 0 represents no preservation, and 1 represents perfect preservation of local relationships. I see this as a true statement. If the score is low, that's a strong indicator that the chosen dimensionality reduction technique, t-SNE in this case, isn't suitable because it fails to reveal the underlying data structure effectively. I note this refers to data with many features or variables, making visualization difficult. I see this refers to the numerical result of the trustworthiness calculation, measuring the quality of the dimensionality reduction result. T-distributed stochastic neighbor embedding is the dimensionality reduction algorithm used in this case. I note this is the result of applying t-SNE, a lower dimensional representation of high-dimensional data that is easier to visualize. I'm focusing on the trustworthiness score, a key metric in evaluating how well t-distributed stochastic neighbor embedding, t-SNE, preserves the relationships between data points when reducing dimensions. It measures how similar the neighborhoods are before and after the dimension reduction. A higher score means T-SNE did a better job of keeping those relationships intact. This question tests your understanding of the trustworthiness score and what it means in the context of using T-SNE. Are you ready to test your knowledge? Let's dive in. A score of 1.0 means that T-SNE flawlessly maintained the neighborhood structure, a perfect result. Think of it like a perfect photocopy. Every detail remains the same. This is incorrect. A score close to 0 signifies the opposite, poor preservation of the original relationships. Think of a blurry photo. Details are lost. Correct. The score ranges from 0, worst possible preservation, to 1, perfect preservation. It's a convenient scale for interpreting the performance of T-SNE. Absolutely. A low score is a red flag suggesting that T-SNE may not be the ideal method for your specific data. It might not be capturing the underlying structure well, and other methods might be more appropriate. I'm referring to the initial dataset that likely has many features or dimensions. T-SNE aims to reduce these dimensions for easier visualization without losing crucial information about the data points' relationships. This is the result of applying T-SNE. It is the lower dimensional representation of the high-dimensional data, usually 2D or 3D, allowing visualization in a scatter plot or similar representation. T-SNE stands for T-Distributed Stochastic Neighbor Embedding. It's a popular algorithm for dimensionality reduction, particularly useful for visualizing high-dimensional data in a lower dimensional space while attempting to preserve the local neighborhood structure.